In today's video, we'll be taking a look at marginal functions, our first application of the derivative. All right, throughout this video, we're going to be looking at marginal cost, marginal revenue, marginal profit, as well as average cost, average revenue, average profit, average marginal cost, average marginal revenue, average marginal profit, and we'll be concluding by looking at the elasticity of demand. We begin with the marginal functions. Now recall that we represent a cost function with a c of x. We represent the revenue function with a capital R of x. And we represent the profit function with a capital P of x. That looks like a P of V. P of x. Now for the marginals. Marginal cost is simply the derivative of the cost function with respect to x. And what this does is it'll give an approximation or an approximate cost for producing the x plus 1 item, or the x plus 1 unit. Next up, we have the marginal revenue function, which is dr dx. So it's the derivative of revenue with respect to x. And this will give an approximate revenue for producing, or I should say for selling the x plus 1 item. And finally, we have the marginal profit, which is simply the derivative of the profit with respect to x. And it gives an approximate profit for the for selling the x plus 1 item. We now focus on the average functions. Right? So we have average cost, which is represented as c bar of x, which is just simply cost of producing x units divided by x. Right? So c of x over x. Average revenue, which is represented as r bar of x, is just revenue divided by x. And average profit, represented p bar of x, is just profit over x. Well, we also have marginal functions for these. So we can have a marginal average cost, which is just dc bar with respect to x, right? So the derivative of the average cost. We also have a marginal average revenue, which is just the derivative of average revenue with respect to x. And we can also have marginal average profit, which is the derivative of average profit with respect to x. If we're given a function f of x, we say that the relative rate of change of f of x is f prime of x divided by f of x. Then the percentage rate of change is the relative rate of change written as a percent. Right, so just take the relative rate of change and multiply by 100%. We use this to define elasticity of demand. Right? What we do is we let P represent the price. We let X represent demand. And we say that price and demand are related by a price-demand function or equation even of the form x equals f of p. Right, so we're relating demand as a function of price. The elasticity of demand it's a function of p, it's e of p, and is defined to be negative relative rate of change of the demand divided by the relative rate of change of the price. In other words, this is equal to negative f prime of p over f of p all over 1 over p. Now if we simplify this, we get as our equation negative p times f prime of p all over f of p. And we say this will give us the elasticity of demand. Now, to interpret it, right? So what exactly is elasticity of demand? Elasticity of demand is always going to be a positive value. And we have three possibilities. The first possibility is that the value, the elasticity, will fall between 0 and 1, in which case we say it is inelastic. What this means, right, so this we'll call demand. Let's make a table out of this. The interpretation. Demand is not sensitive to a change in price. So we say demand not sensitive to change in price, meaning that a change in price will produce a smaller change in demand. So it produces a very small change in demand. Now, in terms of the revenue, what this means is that price increase will increase revenue. Second possibility we have is that E of P, the elasticity, will be larger than 1. In which case, we say the demand is elastic, meaning that the demand is sensitive to change in price. Meaning that a change in price will result in a larger change in demand. So a change in price results in a noticeable change in demand. And in terms of revenue, it means a price increase will decrease revenue. The final possibility we could have is that the elasticity is equal to 1, in which case we say the demand is unit or unitary. In this interpretation, a change in price will produce the same percentage of change in demand. Right? So if prices increased by 10%, the demand will be decreased by 10%. And there is no effect on revenue in the unitary case. We will now look at several examples. Let's start here. So we're told that a company manufactures fuel tanks for cars. Total weekly cost given in dollars of producing X tanks is given by that cost function. We wish to find marginal cost. Find the marginal cost at a production level of 500 tanks per week. Interpret this, and then find the exact cost of producing the 501st tank. All right. Well, for part A, recall that the marginal cost is the derivative of cost, so C prime of x. All right, so we're going to take the derivative of this function up here. That gives us 90 minus 0.1x. All right, for part B, at a production level of 500 tanks per week, we want to find marginal cost, so it's C prime evaluated at 500, which is 90 minus 50, which is $40. The interpretation. At a production level of 500 tanks per week, it will cost approximately $40 to produce the 501st fuel tank. Right, so it'll be another $40 to produce that next fuel tank. To find the exact cost of producing the 501st tank, if we look at the cost of 501, right, that'll give us the total cost of producing 501 fuel tanks. We can then subtract the cost of producing 500 fuel tanks. So C of 501 $42,539.95, so 95 cents, minus $42,500, and that difference comes out to $39.95. For our second example, let's take a look at this. So it says that company's market research department recommends the manufacture and marketing of a new headphone. After suitable test marketing, the research department presents the following price-demand equation, where X is measured in units, it's the units produced, and P is in dollars. The financial department provides the given cost function. We are asked to graph the cost and revenue functions on the same axis and find the marginal cost, revenue, and profit functions. All right. So what we need to do is we need to find revenue, right? We already have the cost function. Now remember, revenue is the number of units sold times the price charged per unit. What we need to do is we'll need to come up here. We need to take that right there and solve it for P. So X is equal to 10,000 minus 1,000P. We'll have X minus 10,000 is equal to negative 1,000P. This gives us a price function of 10 minus 0.001x. Finding domain. This has to be a positive price. And also, x must be positive. So 10 minus 0.001x has to be larger than 0. Or at least 0, I should say. This will mean that 10 is greater than or equal to 0.001x. Multiplied by 0.001, we get 10,000 is greater than or equal to x. So we get as our domain here 0 less than or equal to x less than or equal to 10,000. So our revenue function, which is x times p equals x times that p we just found, 10 minus 0.001x. That is 10x minus 0.001x squared. To plot this, we are going to use, once again, Mathematica. Let's define our cost function, c of x, as 7,000 plus 2x. That was what was given to us. We will then define revenue as what we just found, 10x minus 0.001x squared. All right, now we can go ahead and plot it. So we want c of x and r of x on the same axis. Now we know the domain was 0 to 10,000 for x. Let's go ahead and define colors. So we'll make the cost function blue. And, you know what? Let's change that. Let's make the cost function red and the revenue function blue. And I'm also going to tell Mathematica to automatically label. If I execute this, here's our graph where this red line is the cost and this blue curve represents revenue. Now what I'm going to do is I'm going to go ahead and copy that and bring it back over to here. And the reason for that is so I can examine this. Right? Let's pick a color. Orange will work. I'm actually going to use a highlighter, I think. And we'll highlight in orange. So this little bit in here, like that we see right here, this is, of course, the revenue minus the cost. So what this does is this is representing profit. If we look here, this, again, is revenue minus cost, but now it's negative, right? The cost is over the revenue. This is going to represent a loss, isn't it? And the same thing can be said over here. We cut off at 10,000, so this entire thing over here, I'm not going to worry about coloring all in, is also representing a loss. So the only time that it's profitable is within this region right here. Now let's take a look. We want to find the marginal function, so we're also going to need to find profit, which of course is the revenue minus the cost. Right, so the revenue was 10x minus 0.001x squared minus the cost, which was given as 7,000 plus 2x. This winds up being 8x minus 0.001x squared minus 7,000. Now for all the marginal functions. C prime, the marginal cost, is just 2. R prime, the marginal revenue, is 10. minus 0.002x. And finally, P prime, the marginal profit, is 8 minus 0.002x. For our next example, let's look here. Right, so we're told a small machine shop manufactures drill bits used in petroleum industry. The manager estimates that the total daily cost in dollars of producing X bits is C of X equals 1,000 plus 25X minus 0.1 X squared. We wish to find and interpret C bar of 10 and C bar prime of 10. All right. C bar of 10. So first, C bar of X, remember, is C of X over X, and it represents average cost. Be 1,000 plus 25X minus 0.1 X squared divided by X. 1,000 over X plus 25 minus 0.1 X. Now C bar prime would be negative 1,000 over X squared minus 0.1. C bar of 10, plug in 10, and we will get $124. C bar prime of 10 will get negative $10.10. Now, interpreting these. This here says, at a production level of 10 bits, the average cost is $124 per bit. Now, this does not say that each bit costs exactly $124. It just says that on average, when you produce 10 bits, it's $124 per bit. The C bar prime of 10. Right, so this says at a production level of 10 bits, each additional bit will decrease the average cost by $10.10. Approximately, right? So for each additional bit we produce, we expect the average cost per bit to drop by $10.10. Now let's consider this example. Model for the GDP, which stands for Gross Domestic Product, expressed in billions of $2005, is given by that function, where T is measured in years since 2000. What we wish to do is find the percentage rate of change of the GDP for the years 2000 through 2012. Right, now remember, percentage rate of change was given by 100 times the relative rate of change, which is f prime of t divided by f of t. So 100 times f prime is just 209.5 over f, 209.5t, plus 11,361. Multiplying that by 100, 20,950 divided by 209.5t plus 11,361. So this would be our percentage rate of change as a function of t. Let's now take a look at our next example. So we're given price and demand for a product are related by the given price-demand equation. We are asked to determine where the price, or we're asked to determine the price where demand is inelastic, elastic, and then unitary. First, what we have to do is write the price-demand function as a function of p. So we have to solve for p in this equation, right? This would mean that 500p is 10,000 minus x. Oh, I'm sorry, we have to write this as a function of p. I'm solving for p. I don't want to do that. I want to solve for x. X is 10,000 minus 500p. There we go. We can factor out of 500 and make it 500 times 20 minus p. Now, both price and x must be non-negative, right? From there we can see that 0 would be less than or equal to p, less than or equal to 20. So the price will be between 0 and $20. For inelastic, we want 0 to be less than the elasticity of demand. I'm sorry, I'm skipping a step. We need to first find elasticity of demand. Now that, remember, is given by p times f prime of p all over f of p. So negative p times f prime, which will be negative 500, right? F is this up here. All over that 500 times 20 minus p. Simplifying, the 500s will drop out. The negatives cancel each other out. We're left with p over 20 minus p. For inelastic, remember, we want elasticity to be between 0 and 1. So we want 0 less than p over 20 minus p less than 1. Solve for this. Multiply everything through by that 20 minus p. 0 less than p less than 20 minus p. This means that 2p would be less than 20, or that p itself is less than 10. So for prices between $0 and $10, right? Because remember, 0 is the smallest P can be. The demand would be inelastic. For elastic, remember, we want elasticity of demand to be greater than 1. This means that P is larger than 20 minus P. And using a similar argument above, we find that P is greater than 10. So the demand here is elastic for prices larger than $10. However, remember we said in the domain that the highest P can be is 20. So it's prices between $10 and $20. Unitary, or unit, we want the elasticity of demand to equal 1. Of course, that means that P would have to equal 20 minus P, and so P would equal 10. So demand is unitary. When price is $10. Oh, I wrote prices. Finally, let's consider this example. Manufacturer of sunglasses currently sells one type for $15 a pair. Price and demand are related by the given equation. If the current price is increased, will the revenue increase or decrease? First, we need to find elasticity of demand. So E of P. Now remember, that is negative P times F prime of P over F of P. Now we're already given F of P. It's right here. 9,500 minus 250P. So this gives negative P times negative 250 over 9,500 minus 250P. We want to evaluate this at a price of $15. Or let's simplify this first. This is 250P over 9,500 minus 250P. So evaluate this at a price of 15. Plugging it in, we'll get 15 over 23, which is less than 1. So elasticity is demand is inelastic. Inelastic means that at the current price, increasing the price will result in an increase in revenue. And that concludes today's video on marginal functions. The next video in this series will take a look at another application of the derivative known as a related rates problem, where all we will do in that video is look at several examples of related rates problems. So until next time, take care.